The following is a conversation with Mr. L. Venkatasubramaniam of IBM. He's the quantum lead for IBM India. We talk about AI, quantum mechanics, and how these technologies are going to shape our future. We talk about his new book, Quantum Nation, and many more things. We hope you enjoy.
Yeah, thank you for having me. Actually, I'm very excited. I really love what the book has done because it has put me in touch with youngsters like you who are actually in the field doing things. So it's very exciting for me to talk to you. So I did my PhD in 98, I finished, okay, and that was in the area of communications, okay. It was in what you call information theory, coding theory.
Okay, that's related to quantum. That's related to quantum.
To some extent. Yes, exactly. But after that, when I joined IBM, I joined the speech team. So, in fact, IBM was on IIT campus that time, IIT Delhi campus. So I was thrilled. I just had to move from this building to that building. So I thought, oh, this looks good. Let me try it out. And in there, I started with speech, then did some image processing, then natural language processing, AI, ML, and only about 3 years back, I moved into quantum. Actually, in India, we thought that there was no quantum team in IBM that time in India. So we thought that we should have one. And so a few of us got together part-time and started learning and also building a community around it. It did well. So now we have a largish quantum team here in India, and it's growing also.
Yeah, and is there any hardware team in India?
No. So if you look at the quantum stack, there's the hardware, then middleware, software, algorithms, applications. So the bottom layer is not there in India. Everything else above is here.
Talking about AI, do you think the current AI systems that we have have a sense of understanding?
It's I don't think so, but but it's still surprising, because things like humor, sensitivity, these are things we thought will take a much longer time for AI to get right. Yeah. So, but now if you see, you ask it to generate humorous text, you ask it to generate a joke. These are all things that AI is getting, and these were very special qualities of human beings, we thought, okay. But this AI, which I think is very shallow intelligence at this point, it's not even, in no level of consciousness or anything. At least that's what I think. Already we have reached a level where AI is able to, mimic some of these very human qualities, which to me is very,
if you let Alan Turing interact with one of these systems, he'll surely think it passes this test.
Yes. That's true.
So in that sense, yeah. Just like I am doing my master's here abroad in Germany, what do you think the Indian ecosystem, including the government and the industries, can do to keep the talent in India? What needs to be done for that?
Yeah, so the answer to that is very simple. The answer to that is there needs to be a local industry which works in this area. So I'll give you 3 examples, okay? And it's there in the book also. By 1960, we had a computer in India, the TIFRAC, built in Tata Institute of Fundamental Research. We were one of the first countries to have built a computer, okay? By 1963, we had this computer in Kanpur, a programmable computer. So software had also started. In 63, we had that. In 62, we also were, had this ability to build germanium chips. So we had a fab of that time, right? So hardware, semiconductor, software, all three, we had a head start compared to the rest of the world. Okay. 1984, Semiconductor Limited opened in Chandigarh, and they were ahead of TSMC, Taiwan Semiconductor Manufacturing Company, which started in 87. We were ahead of them. Okay. Now, but we only became a software nation. We did not become a hardware or a semiconductor nation. Why? Because a local industry came up in software. The TCSs, Infosys, HCL, all of these came up in only in the software area. In the other areas, we produce the best talent, the father of Pentium, the father of fiber optics, people who were going to Intel, IBM, all of these companies were from India. A lot of good talent went there. Why? Because, we could not build a local industry either in hardware or in semiconductors. But in software, we did. And that's why at least some of us, find a good job now in India, and we're able to do well. And in quantum, that's what we have to do. We have to build a local industry across the stack, the full stack, hardware, middleware, software, algorithms, applications, all of that.
So you talk about the importance of having a full stack in the book. So currently, from my understanding, I think India in the software stack for quantum, or in the stack of quantum computing, we have already publishing results on the software and the middleware side, but not so much on the hardware side. Is that a right assumption to make, or are there advances?
Actually, in hardware, we have some very good people. Okay, for example, Dr. Vijay Raghavan in VIFR, Vibhor Singh, ISC, Baladitya Suri, ISC. There are people in TCG Crest. Actually, the ISER Pune, a lot of these institutions actually have people who have been working for the past 2, 3, 4 years, working in superconducting qubits, working in ion traps, all of this. Okay, so there is actually people working in the hardware field, but as you know, in the software, it's much easier because there is a lot of talent in India. Okay, because it's easy for somebody who's working in AI. In fact, I used to work in AI, and now I transitioned into quantum AI, quantum ML, all of that, right? So in the software field, it's somewhat easier for India because we built a history around it. We have a culture around it, right? In hardware, if you have to build that test bed, or you want to build out your qubits and build the middleware and everything on top, the peripherals, control systems, everything has to be imported today. Okay, everything, so Vijay Raghavan has built a lab. They've invested a lot of money in that. Yes, they have, I think they're about to reach 9 qubits or so. So it's there, and there are some good papers also coming out, but I think we will need more patience. We'll need more hard work on that side compared to the others where we have a legacy of 50, 60 years now of having done decently good software work. We have an industry, we have people working in the area. It's much easier. Whereas here we have to put in more effort. And I think people are seized of that. They understand that. The government understands it. The professors also understand it. So it's going on, but as I said, it's a bit harder to do it there.
So with the announcement of the National Quantum Mission, do you think funding will be an issue anymore? Or if funding wouldn't be an issue, what do you think will be the biggest hurdle for India to assume its position in the coming quantum future?
See, funding will be an issue because how much has the government committed. It's 6,000 crores. Okay, 6,000
Yeah.
crores. If you look at investments that have happened in quantum across the world, where people have built systems, right? Whether it's in the US or Canada or these countries.
Australia.
Australia, over the past 20 odd years, they have been putting money, which has been much more than this 6,000 crores that we are going to put in. Okay. So what are we asking our scientists to do? We are telling our scientists that, something people took 20 years, you do it in 5 years now, and I'm going to give you money, which is a fraction of what the others have already put in. Okay. So, but that's not to say we'll not achieve something big. Okay. I'm just telling you the hard starting line for the Indian scientists today. Okay. It is a starting line where they are already at a disadvantage. Okay. But we have seen in areas like, if you look at ISRO, we all say that these, ISRO has used, they spend much less, but do the same thing much better. Okay. So there is that ability, the capability is there, but we still need to invest more. Okay. So this is just seed money, according to me, the 6,000 crores. Now industry has to come in. If you look at other countries, the major investment is always from the private sector, because no matter how good the university is, no matter how good the university professor is, they are not set up for going and marketing and selling and building an industry out of it. They can't do it because they're not made for that. They can produce good technology, but now Indian industry has to come in and take that and make an industry out of it, just like we did in software. Okay. So in the 60s, there were these IIT Kanpur professors who would take a lot of courses. F.C. Kohli, the father of our IT industry, he would go sit there, take those courses and try and understand, okay, this computer is here. How do I use it in my industry? What do I do? So in 1968, when he started TCS, he already had some understanding that, okay, this is how computers are used, because he went every month to Kanpur campus, sat through these courses from professors, tried to rack his brains, and his top leadership also used to go. So they figured it out. Now, if you look at Narayan Murthy, he was from the 1967, he joined the IIT Kanpur second master's batch there. And he had this head start in terms of looking at computers, using them. So by the time he started in 81 with Infosys, he had an idea where, what do I do with this? Similarly, we need to, give this opportunity to our youngsters to have access to quantum computers, to have access to, these labs where they can do all the experiments. But then we need to provide them an opportunity to take that and create an industry out of it, just like Narayan Murthy did, just like F.C. Kohli did. Because if we don't, then you'll have a Vinod Dham who will learn everything here, then he'll go and he'll build a industry somewhere else outside India. Okay. So that's something we have to do. We have to use this talent, which is immense, to build a local industry.
What do you think is the biggest hurdle to do that? If funding is one issue and keeping the talent here is another, but is it just about the money, or is there anything else that needs to be done to foster an ecosystem in India?
Yeah, so see, I mean, I in IBM, I get this global view across the world of what industries are doing, right? So I see that the industries in other countries are already looking at exploring quantum. They're using the systems to see, if for example, if a financial company, so they're looking at how can I do fraud detection? How can I do portfolio optimization. So several banks have already started looking at it across the world. Okay. Similarly, in the pharma sector, they're looking at protein folding, drug discovery, all of that, right? In the industry. In India, I see that happening more in the academia. I see it happening in the government labs like CDAC, but I don't see it happening in the industry, which is the crucial piece. The industry has to step in. Only then does it benefit the country. If you just leave it to the labs, then the PhD students, the master's students, they will never find the jobs because there is no industry locally, and they will have to go out. They will have to. There is no way. You can't train a guy with the best, skills in PhDs, publishing in Nature and some good, journals and all. And then you say, okay, now I don't have a job for you. So what is that poor guy going to do? He's going to go where the job is. So we have to create that local industry.
So is that up to the leading industry players like Infosys and TCG, Crest and Tata, or do new founders have a chance in this industry? Because it's a very specialized and deep tech field. So do new founders stand a chance in this industry?
Yeah, so, when I was visiting IIT Madras, okay, Professor Ashok Jhunjhunwala, he told me, industry in India has been a little slow in adopting deep tech, research, all of that. But what I find is the youngsters don't want to, wait. They want to, and so if you look at IIT Madras Research Park, they have created you saw Agnikul, they launched that rocket recently, right? That's deep tech. It is rocket science, right? I mean, we always say this is rocket science is the toughest science, right? So they are doing rocket science, and these are, kids who came out of colleges, no PhDs there in that team. Okay. They got some seed money from IIT Madras. Now they're doing decently well. They've raised money. I'm sure if they were in some other country, they might have scaled much faster, but that's okay. They still are doing a great job, right? And so the one thing I remember from what Ashok Jhunjhunwala said is that when industry does not step in, we need to enable these youngsters to do startups, because that's where that innovation and industry is going to come out of. Okay. And we can't wait for industry to adopt. We have to enable these people. Okay. And in the National Quantum Mission, the National Quantum Mission, leadership has already invited a lot of the startups in India, had sessions with them, presented. So I believe, some of this money will go to them. I think ideally what will happen is that they're going to set up these 4 thematic hubs, right? Computing, communications, sensing, materials. 4 thematic hubs will be set up across India. And I think what should ideally happen is that they will tag the startups to these, Since startups go there. So what will happen is some of the central facilities, like labs and stuff for doing experiments or to access quantum computers to run their algorithms and stuff, will be made available to these startups. Okay. So that, sort of ecosystem will get created for these people. So I mean, I believe that's a good approach. That's a good way, because you can give some money to the startups, but this is a way to sort of enable many startups. And then hopefully VCs will come in, and others will also come in, because the risk is mitigated, right? I mean, for a VC, if there are 4 kids from IIT, one of the IITs, and they have to invest in them all the money, then all the risk is with that VC, right? Now you're saying the government is saying, I'm going to set up some central facilities. I'm going to enable them. I'm going to give them some training, mentorship, and then you can come in when we have some level of something big. Yeah.
Yeah. So for all this to happen, what do you think the role of education is, and where are we in that?
Yeah. See, but in India, I mean, I see immense talent. Okay, that's the one very good thing. And if you look at it, I mean, there are some very surprising things happening. Okay, number one, how many colleges have quantum computing as a subject? Maybe 10, maybe not even 10. Okay, maybe 5. Okay, how many colleges offer even one course in quantum computing? Maybe 15 maximum per year. Okay, but the number of so all you add all of this up, it's a few hundred, maybe 100, 200 max. Okay, but when we run these IBM, summer schools, you look at the IBM certification. You look at, I've seen reports from other companies also, non-IBM. Okay, they're all saying, the usage on our computers is very high from India. Okay, it's very high. And so which means that kids who are not getting training in their college in quantum computing are actually doing self-learning, and they are going and using these systems, right? That's one. The other is, we ran this NPTEL program, which is the MOOC for India, where you find all these free courses, okay, run by some of the best professors in India. In that, we offered this quantum computing, okay, along with IIT Madras plus IBM, we offered this. 15,000 students registered over 2 years without any advertising or anything. They found out. The biggest surprise to me was that 1/3 of those students were 12th class students. Okay, where are they coming from? What's going on? Because in 11th, they're given a little bit of Heisenberg and all that as part of chemistry. In physics, 11th, 12th, nothing is taught about quantum mechanics. Okay, but somehow these kids are finding it so intriguing, so interesting. So which leads me to this question of what is going on? I mean, why are these kids so interested in this subject, which nobody is teaching them? Self-interest. They're just going, looking up videos on YouTube and look at the Qiskit textbook. It is there in Hindi. It is there in Tamil. Do you have Java textbooks in those languages? Do you have Python textbooks? But something is happening in quantum. I don't know what's going on. So in the book, I tried to relate it to maybe, it's our ancient textbooks where there are these concepts about, which are very similar to quantum mechanics, which I feel, so maybe as kids, we hear these stories and all of that. And now we find that, oh, there is science also here, which is related to these stories we heard as children. And maybe that's what's intriguing them. But something is happening, okay, so which is very, very surprising and very, very, heartening also. Very nice to see also that these young kids, without anything, are going and learning on their own.
Yeah. I mean, maybe it has something to do with quantum mechanics is a subject that stumped Einstein. So they are intrigued themselves to find out what is so puzzling about it.
Yeah, but remember, that can happen in any country, right? Why is it happening more in India is my thinking, because everybody today is exposed to all those stories about Einstein not believing in quantum mechanics, saying things like, does God play dice with the universe, spooky action at a distance. So all these, famous utterances and people saying that, oh, nobody understands quantum mechanics, the big scientists saying these sort of things. So yeah, it is all there, but I mean, then everybody in the world should maybe follow this path. So yeah, I mean, my thinking. I don't know, but I don't think there is any correct answer, or anybody knows why it is happening. Maybe we'll know in a few years.
Yeah, I mean, India, there is, kids are always fascinated, and so
Yeah.
I guess that may be it. So I want to ask you a slightly philosophical question, I guess. Uh, according to you, according to your opinion or your line of thought, what do you think the electron does when you're not looking at it? What is the electron when you're not observing?
Yeah, I don't know. I mean, it's very interesting, you know. I mean, the electron and the atom, I always think of it like
Yeah.
the solar system, you know. I mean, something, there's sun in the middle and going around, and from the time we were introduced in school, right, about all these things. So I mean, it's very difficult to, in fact, to me, I would say, I just imagine it like this earth going around, and but then it has all these special wave particle, you know, behavior. It has a particle nature to it. It's very intriguing. Yeah.
Yeah, I mean,
And,
what
and
I
you
just,
know, the other thing is, you know, this makes me feel that maybe I should have studied physics as my, you know, subject in, uh, because, you know, I say a lot of kids now believing that, you know, there were these few years in India, like the past 20 years, right, where everybody was going into, you know, computer science. You know, there are now universities in India which have only data science, computer science, IT, only 5 branches, all of them variants of computer science, you know. And this was happening. And now suddenly you know, there is so much interest in physics and all of that. And all the science students, chemistry, physics, all of them now feel that, oh, here is a chance for me now, you know, I can use this core knowledge, which I'm so excited about. I don't have to go and start just programming and learning computer science just because I need to find a job. Now, maybe there are going to be jobs in this also. So that's good. But yeah, I mean, as I was starting to say, I still feel that maybe I should have learned more physics. I mean, because some of these things, now that quantum computing has come in, I don't get it. Okay, I don't get it, and I want to get it. Okay,
nobody
so
does. Yeah, that's the thing. You don't need to actually be a physicist to use quantum
exactly.
computers.
Yeah. Right.
But like coming back to the question, do you think there is a reality when there is no observer looking at it? Or are you a Copenhagenist or are you a realist? Is what I'm trying to ask.
Okay. No, I think there is, of course, a reality when no one is looking also, right? So, yeah, but these kind of deep questions, I don't know. I mean, I've not
Again,
even
nobody has
thought about
answers to
it.
these.
Yeah.
Yeah, sir. Just want to like know what you thought of that, I guess. But on a serious note, where do you think quantum computing or quantum as an industry will have the most impact? One, in the next 5 years, and two, in the next 50 years.
Yeah. So, see, it's always very tough to predict where the industry will go, you know, like internet, okay? Internet
Yeah.
came up in the 80s, and then once the penetration reached, so there is a inflection point, which is usually 10 million, okay? So at 10 million users, internet in the US, you had Jeff Bezos, a 30-year-old that time, start Amazon, okay, 1994. After that, you saw a slew of internet companies come up, right? So in India, that 10 million number was reached about 10 years later. Okay, 1993, it was reached in the US, but in India, we only reached that number in early 2000s. Okay, and hence, the Amazon equivalent in India, Flipkart, when did it start? To year 2007. Okay, year 2007, two 25-year-olds came in and started that company. Okay. So, and these are not things that Tim Berners-Lee or any of the founders of the internet imagined, right? I mean, these are all creative youngsters who have once been exposed to this technology. They take over. It takes a life of its own, right? Today, who thought that, all of us Indians will be paying using our mobile phones in the rural areas, in urban areas, everywhere, this whole digital stack that we have built, nobody imagined it, right? But in quantum, I mean, some of the early things that I can start to foresee. One is, of course, the whole chemistry, life sciences area. Okay, the whole molecular simulation things. So whether it is life sciences, and even things like electric batteries, new materials, that's one very big class of area where we are going to, I think, see some of the early advantages. Okay. The other is finance. Okay. And finance, why? Why? Because I'm seeing a lot of financial institutions embrace quantum, starting to look for applications. So when you start looking, you'll find it. Okay. It's only a matter of time. In fact, even in India, I was very happy to see this, the CIO of Axis Bank say that he started looking at quantum applications in their banking. Okay. So finance, certainly, because they are an industry that have started looking at it right now, which is great. So in the next 5 years, I believe these are the two industries where we are going to see some early things, and maybe this quantum advantage is going to come from one of these two. Is my belief. Yeah.
And what about in the next 50 years? What do you, in long term, where do you see quantum having the most socioeconomic impact?
Yes, you see the national.
I know it's very hard, but I know it's very hard to predict.
Yeah, I know it's hard, but the hope, or I mean, at least I hope, okay, which is that the National Quantum Mission, what is its goal? The goal is that we must become a quantum-driven economy. Okay, what does that mean? Like, I don't know, in the 90s, you were probably not even born. So at that time, computers came, right, in India. So my parents, maybe your parents also, all of them, their companies or even the government, my parents worked in the government, they were sent for these computerization classes. Okay, what did they do? They went and learned word processing. They were taught Excel and, doing some basic number crunching and all of that. Okay. And this is what across India, the government, private industry, everybody went, said, go and start, using these new devices, because we will computerize everything. We will throw away the paper. And so this was one very big reason for the computerization, throwing away the paper, putting everything on that device. Okay. So what is that killer use case for quantum computing? Okay. I don't see it immediately becoming a mass business B2C, at this point, where consumers start using quantum applications and stuff. Okay. But in the next 50 years, I believe that's what is going to happen. Okay. I don't know what those applications are going to be. And that's going to be the turning point. Okay. You look at AI. AI, until it was a business tool, okay, AI is there, people used to say. But as soon as it came in the hands of the consumers and they started using it, suddenly, there is a boom, and we are going to see so many applications. We are going to see people, jobs, the role of people changing. A lot of the work we do today is going to get transformed into new kind of work that people will start doing. Okay. For that to happen, quantum and in the next 50 years, that's what's going to happen with quantum. You're going to start seeing real life applications which will take quantum computing closer to the layperson or the individual. And what I really like about, one thing I like among all the national quantum missions, I like what Japan is trying to, which they're saying that by 2030, we are going to have 10 million users. Okay, remember internet 10 million was an inflection point both in India, in the US, everywhere. Similarly, what their thing is, how do we put quantum computing in the hands of people so that quantum computing takes life of its own? It's not limited to those 100 experts or those 200 scientists. It's now a mass thing, and now youngsters who just come fresh out of college, they can think, oh, okay, I can use this for this. And that's what changed computing, and that's what will change quantum computing also.
Sure. So you touched on this earlier, but what would be the cost of being late to the quantum party or quantum computing party for governments and the private sector?
Yeah, I mean, see, internet, we were late. So hence, we were late with, Amazon came in 1994, Flipkart came in 2007. Uber came somewhere, then came Ola. Similarly, many things happened. And then the Indian innovation came when we built that digital stack, okay, the whole payment system and all of that. That's when the local industry took over. Okay, the local talent took over. It took us how long? Internet penetration reached 10 million around 2001, 2002. In about 10 to 15 years, our local industry here matured. Our local, youngsters matured, and you started seeing unicorns, and you started seeing all these very good startups come out of India, right? So it took that much time, right? So with any technology, it takes that time. Okay. Maybe a little bit compressed. Okay. I mean, we are seeing that compression happen. But if you come late, there is this challenge then, that how do you, it will take you that 15 years from the time you reach a certain level, that 10 million in that case, right? So if some other country is going to reach there 10 years before you or 15 years before you, you're always going to play catch up. What are we doing in semiconductors today? 1984, we had a beautiful lab in Chandigarh. We were ahead, but we did not convert that into an industry. We didn't do it. Taiwan did it. They did it. Now, what? How many years later? Like all these years later in 2024, we are paying through our noses to invite all these semiconductor companies to come and set up fabs in India for technology which is 7 to 8 generations behind. Okay, we are paying billions of dollars now for technology which is not current day technology. We are saying, 28 nanometer fabs, 40 nanometers, come and set up those fabs for us, not the 5 nanometer or the 7 or the 10 or the 12. We are saying 28, 50, all of that, okay? For that, we are paying this, okay, this money. Now imagine if a fraction of this money we had invested at that time, in 1984, to convert that lead which we had into a real industry, okay? Imagine where we would be, so, but we need the visionaries, we need the kids who are willing to do this, because all it takes is, youngsters to sit there and say, I'm going to do it. And then they will, there's nothing which will stop them. Okay. It happens naturally. You learn, you'll make mistakes for 3-4 years, and then you will pivot and do all sorts of things. HCL, I don't know if you know HCL, right? HCL, when it started as a hardware company, They built microcomputers, what we call PCs now, they were competitors to Apple. At that time, there were very few companies around the world which were building these microcomputers. Okay. They built it, but we did not give them the right, um, atmosphere in India. We had all these duties and all those things, customs duty and license and all these things. And so HCL, even though they had a head start in hardware, they could never become a hardware company. They were smart. They pivoted to software. Now we know them as a software company. So youngsters, I have no doubt, will do well. They will figure out, if this is not going well, they'll pivot to something else. But, we have to give them that chance. We have to give them that opportunity, which brings us back to the question of, we need to build this local industry. That's the only way we will thrive. Otherwise we will have built a SCL somewhere, and so what? I mean, it didn't do anything for us.
So, what would be what is your favorite qubit? And you can't say superconducting. So, what's your favorite qubit?
Room temperature ones. Okay.
So what are room temperature ones? Trapped ions?
Yeah, and maybe photonic, all of these, I mean, of
Yeah.
course, people have they still have a lot of problems. But if they succeed, I mean, that's what you really want them to succeed, right? I mean,
Yeah. Do you think scaling would be an issue for superconducting qubits?
yeah, we are already seeing that, right? I mean, so if you look at IBM, IBM launched the 1000 qubit last year, and also the 133, and which is the better performing one in terms of noise, in terms of everything. It's the 133. Okay, so
But
now
in terms of actual results and like quantum volume and quantum depth, the 1000 qubit machine is better, right?
no, the 133. Yeah.
I didn't know that.
Yeah. So okay, so that, so what is IBM going to do now? We are going to connect processors, saying that yes, this 133 will scale up. It will become bigger and bigger, more qubits in there. But 1000 going to 2000, going to 4000 is going to happen by interconnecting smaller processors at this point of time. Okay. So yes, there is there are some barriers there, but I think, if you listen to the scientists from IBM clearly, what they're saying is we have the science figured out. Now it's more an engineering thing, and we'll do it. Okay, so if you look at the IBM roadmap, by 2033, reaching 1 lakh qubits, all of that, right? So it's there, but is it going to be one big processor? Not yet. It's going to be multiple processors connected to each other, which also means that you now have to come up with algorithms which, so within the processor, you will have entanglement. But processor to processor, you have to figure out now, how are you going to take your big problem and split it up into pieces and then all stitch it all back together. So all of those questions are very interesting questions because of the way the hardware is evolving, will be presented now.
Maybe like an interplay of distributed and quantum computing.
Yeah. And remember, there is also the HPC in there, CPUs and GPUs, so definitely some of your processing happens there also, right? So how do you stitch it all together? So there is going to be a golden era, if you might call it so, for algorithm developers who are going to come up with all these, very nice ways of exploiting all the CPU, GPU, and QPU that you have. all of them with their own special properties and all of that. How do you break up your big problem into things which will go there and then solve your big problems, of science and technology?
Yeah, that's one way. But when do you think we'll have a machine of at least, like, let's say 200 perfect qubits, like fault tolerant, clean, perfect, error corrected qubits? 200. And I've heard that 200 is the number where you can concretely see quantum advantage. So when
Yeah.
do you think that we'll see that?
Yeah, so I think that's at least about 7-8 years away. Okay. But that doesn't mean we'll not reach quantum advantage. Okay. Because if
Before
you,
that.
yeah, before that. Okay.
Uh-huh.
So even before error correction, I think we are going to start seeing good applications where we will do smart things. It might not be quantum alone. Maybe it's quantum plus HPC, but we will see some problems being done which we can't do otherwise. Okay, so whether people will call it quantum advantage or they will give all the credit to saying that no, that was only the the classical doing all the work, but I think there will be some breakthroughs which will happen in the near future, well before we reach that 200 logical qubits number, where we will solve some important problems, maybe using a combination of classical plus quantum, but we will see quantum have an important play in there.
So you have worked in AI before you moved into quantum. So what do you think quantum can do for AI and vice versa?
Yeah. See, AI doing things for quantum is very simple. Okay. For example, code generation, Qiskit code generation. It's already happening, right? For example, if you wanted to build a RAG model to give support for scientists, if you want to ask questions about quantum science and you have all the research papers entered in there. So those kind of things we will see in the very near future, right? In fact, some of that is already happening, right? It's happening in IBM, in my team, right? So those are things which will happen immediately. Okay, you're going to see the benefits of bringing AI into quantum in the immediate future. Even things like transpilation, even
I mean,
error.
the quantum challenge had the introduction of the transpiler.
Exactly. Yes,
Yeah,
yes.
yeah.
So all of these are things which anybody who is good at AI will easily just start applying. Okay, so that's the first phase when we are going to see all of this, right? The other phase is where we are now beginning to use quantum for AI, right? Like you said, in applications. And I always like to give this example, like when we were kids, how many cats did we have to see to say this is a cat? Maybe 2 cats, okay, maybe 3 max, okay. But to an AI system, you need to show it thousands of cats. You have to show it black cat, white cat, cat turned like this, cat, occluded cat, all sorts of cats, right? Thousands of them. Now, we are seeing some early evidence that with quantum, if this is human, this is, your classical AI, the quantum is somewhere closer. You don't need thousands of examples. You probably need a few, maybe not just 1 or 2, but fewer. Okay. I mean, a few more, right? So that sort of evidence we are beginning to see. Okay. We are beginning to see that quantum has its advantages in AI. Okay. In fact, there was this paper which showed that quantum is able to make out boundaries where classical will only see white noise. It will not make out anything there. So
For
there is,
signal processing.
yeah, I mean, in machine learning, boundaries and classification and
Okay,
all
yeah.
those
Yeah,
tasks, right?
yeah,
So,
yeah.
yeah, and even in signal processing, I mean, if you were to go and, classify your signals into some patterns that you want to see, right? So there is this early things that we are already observing, right? That quantum has its advantages, and there have been some decent papers also on this topic, which are showing some interesting results, but no quantum advantage yet, right? It's not there yet, but we are seeing early evidence, and I think we'll get there in the coming years, maybe 2 years max. We'll see some good results out of that.
So I don't want to take up too much of your time. So I just want to ask you one last question. What advice do you have for youngsters and other professionals looking to get into the quantum field in general?
Yeah, so I think, I see a lot of youngsters now getting into quantum, right? A lot of people are getting into quantum, but they're all solving toy problems. Okay, so they go do simple things, which are there in the textbook, or which they. So I feel a level of mentorship is missing. Okay, and in the apps, I mean, I would ideally like that some of our large companies in India come out with problems. If you're a finance company, you can say that here are some tough problems from my side. If you're a pharma company, you can say that, because, this talent pool can solve much tougher problems than they are attempting right now. Okay. I just want them to have that guidance, for example, in summer school and things. But the summer school is only 2 weeks, right? What about the rest of the weeks of the year? Don't go and solve tiny little problems. Have a big aim, try to solve something big, and ideally go and do a startup out of that big thing that you're trying to solve. Of course, not everyone is cut out for doing startups also, that's fine, but go to places where you will solve tough problems, because that's what will bring the difference between just doing something and doing something useful and important.
Yeah, with that, I guess this is a nice place to stop. Thank you for coming on. And
Yeah, thanks a lot, Hari. I mean, I really enjoyed this, and thanks for giving me this chance, because as I said, only after I published the book, now I get a lot of these opportunities now I'm getting, and I like it, because I feel there is something here to make a change for, especially in India, because of the talent that we are seeing here and the interest among youngsters. So it's now that, like you asked this question of what will we do with quantum in the next 50 years, I think that answer will come from, kids like you and everybody else, and we just need to be tuned in and give that chance. If people have that access, they have a chance to build something, I'm sure something great is going to, several great things are going to come out of this.